For this video, we're going to work on understanding relationships between polynomial equations and their graphs, and how to predict the shape of a graph from its formula. Okay, so there are a number of different techniques you can use to determine the key features of a graph from its equation. A first-degree polynomial equation, such as y equals mx plus b, or in this case just x equals y, will be a straight line. Because there are no exponents, x and y will increase at a consistent rate, and the slope will remain the same for the entire graph. A second-degree polynomial will be a curve called a parabola. A standard parabola will be symmetrical across a vertical axis because x squared will be positive when x is positive and when x is negative. A third-degree polynomial will typically have two curves or turning points. A good rule to know is that an equation of n degrees can have as many as n-1 turning points in the graph, although there are often fewer. Let's look at an equation and see what other information we can learn about its graph. We have x squared plus 10x plus 21. Because this is a second-degree polynomial, we know that it will form a parabola. But will the parabola open upwards, or will it open downwards? We can figure this out by looking at the end behavior of the graph. If large negative and positive x values produce positive y values, as in the top graph, then the ends of the graphs will increase the further they get from the parabola's vertex, and the parabola will open upward. If large x values produce negative y values, as in the bottom graph, then the parabola opens downward. These values all depend on the x squared coefficient. If it is negative, then the parabola opens downward. If it's positive, then the parabola opens upward. The upper parabola has a coefficient of positive 1, so it opens upward, and the lower parabola has a coefficient of negative 1, so it opens downward. So we know that our parabola opens upward. The ends will steadily increase. Now we know the general shape of the graph. It is a parabola with a vertex at the bottom, opening upward. But where in the plane is the parabola located? Finding the x and y intercepts will help us place it and determine the width of the shape. The x-intercepts are found by locating the roots of the polynomial. First we need to factor it, and we can easily rewrite the equation to x plus 7 times x plus 3. So we know that negative 7 and negative 3 are our roots and our x-intercepts, and we can mark that on the graph. The y-intercept is very easy to find. Because x equals 0 when the graph crosses the y-axis, we can ignore all the terms that have x in them and just look at the constant. And so the y-intercept for this parabola is 21. So now that we know the shape, direction, and major points in our graph, we can draw an approximate shape for it. And looking at the real graph, we can see the approximation and the solution are very close. So that's how you can look at a polynomial and approximate its graph.